All right, this is a section on instrumentation symbols. We'll be talking about piping and instrumentation diagrams. They are sometimes called process and instrumentation diagrams, so P and I. Either one is correct. Some people call it one thing, some people call it another. They show the layout of an entire process or a section or a portion of the process. Sometimes you'll have a piece on one page, a piece on another page, simply because it's so big. It shows the four basic concepts, four basic things: the process flow, the major system components, the different types of signals used, and the interconnections between the components. That's so that it makes it easy for you to understand the whole process, what goes into it, and everything involved. Here is a basic diagram that shows a tank. So some of the ones that we've seen so far in some of our lab stuff. We have a tank. We have some valves. We have an orifice plate. We have labels. And these labels will tell us what they represent. TV tells us it is a valve. TIC is a temperature indicator. TT is a tank. These are the tags. Flow transmitter, flow element, flow valve, blah, 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 things like that. It generally shows only the major components. It doesn't show you where it's at. So this may be located a half a mile from here, from the tank itself, or it could be sitting right next to it. You don't know that by indicating it. Generally, when you get down to the labels what can give you some indication of that, of where they're located from there. And we can get into that at another time. They only focus on loops and things like that. That's sometimes why they're sometimes called a loop diagram. And they're used for troubleshooting. A lot easier, if you're following your instrumentation. And a well-designed operator interface or a human interface device will be set up so that it will look very similar to these diagrams, and you can troubleshoot when you have live data coming in as to what that flow valve, what its position says it is, what the flow transmitter, what flow rate's going through it at that time. We've seen some of those with our labs. Now, the individual lines going in between some of the symbols, or the instruments and valves, flow control elements, and things like that, they actually mean something. You have the thick process piping line, line. Process connection is the smaller one. A pneumatic line is a line with two lines through it. An electrical line, you'll see sometimes one line with three, although more commonly you'll see a dotted line. Hydraulic line is a single line with an L in it. Think hydraulic for hydraulic lines. X is a capillary line, which is a secondary air line. Then you have ultrasonic waves. If the little signal is on the line, it means it's guided. When there's no line visible there, it means it's unguided. Ultrasonic waves are used generally to measure level controls and things like that, and level. Then you got an internal system link with open zeros and a mechanical link with the dots in the middle. A little more in-depth description. Process piping is the main flow of the line of materials, and the process connection is one that taps into the main line. So you may have something that, sending a part of your process to another area, and that'll be the process connection. So that's the interconnections. The process piping is the main flow as it flows through its process. Excuse me. A pneumatic line is a line that carries a compressed gas. Usually we reserve pneumatic lines for compressed air, breathable air and things like that. It'll be just under a certain pressure. We try not to use, natural gas or something like that in a flammable substance in a pneumatic line. Electrical line is self-explanatory. It's between electrical devices. And a hydraulic line carries hydraulic fluid. Capillaries, like I said, small diameter tubes for signal transmissions, and we talked about the ultrasonics. Internal system link, software emulation, and the mechanical is a mechanical connection. We have one modification that we sometimes see, and that's considered a binary connection. And this can be done on a lot of things. You see the reverse slash on the line without an electric or like that. That means it is, on and off signals only. It's not an analog continuous changing signal. It's either on or it's off. I'll spend some time and go through these and study these. I won't go through them here. Okay. Let's look at some valve and pump symbols. Generally, when we're talking about any kind of process system, our final control element, or FCE, is going to be a pump or a valve of some type. We're either opening something, closing something, or pushing fluid down the line. That's generally what happens in these kinds of instrumentations. And you would think there would be not that many different types, but there's all sorts of types of valves and things. Here's a basic bow tie valve, which is called that simply because it looks like a bow tie. The one that you have out in your house may be more like a bow tie. Here are some different valve types. An angle valve, then a butterfly. It's generally it's a valve. It looks like the wings of the butterfly in it. And you turn it. It'll only go a quarter turn, so it's either all the way open or all the way closed. Well, you can't go too far, too many different ways with it. A rotary or a ball valve is generally one that moves up and down or into and out of the hole, cutting some of it off. A three-way valve is just that. You have three possible ports and four-way is a four-way valve. You got a globe valve, which is sort of a combination rotary and a bow tie. Then you have a diagram valve, pinch valve, plug valves, and a needle valve. A needle valve is one where you don't need a whole lot of flow. So you have the small plug that you pull in and out with your actuator. Speaking of actuators, we have several types of, every valve is going to have some kind of actuator. It's going to be a manual actuator like this one is shown here, or it can be a hand actuator like this. It can be a pneumatic actuator, which you send air to it, and depending on how much air you send down to it, is how open or closed the valve goes. You have a solenoid. In this case, it is a bang-bang solenoid. It means it's on or it's off, and it's not in between. There are some solenoids that you send like half the value, and it goes halfway. And then you have motors actuators, which you send electrical signal to the motor to open and close the motor, open and close the valve via the motor. Now, generally, the motor is going to be for very big. It's generally used only for big valves and things like that when it's real too heavy for a simple actuator or a simple pneumatic actuator to open and close. Sometimes they'll have outside positioners that allow you to change things, preset it, and helps you give finer control of your actuator. The thing to understand about this is for every valve, there's going to be some kind of actuator. And a lot of times you can take a manual actuator like this and replace it with a diaphragm actuator. You may have a hard time finding the one that you can do that with, the exact one that'll fit, but it can be done. Here's more identifying symbols, blah, blah, blah. Pumps. The other final control element we generally talk about are pumps. And it's what gets things from one area to the next. We generally talk about three main types. That is just a centrifugal pump, a rotary pump, and a reciprocating pump. Now, that doesn't mean that's the only types of pumps. There's lots of different types of pumps out there, but these are the ones that we concentrate on here. A centrifugal pump is one that just actually it looks like this. It flows. There's a motor circulating that, and it circulates fluid. Rotary pump looks more like a mixer, whereas reciprocating bounces back and forth. Think of a reciprocating pump more like what you would do when you're pumping up a tire with a hand pump on a bicycle. That's a reciprocating style pump. Okay, that's it for this one. I'll talk about the next one in the next lecture.